Welcome to Altair Engineering Training and Support. The topic which I am going to cover on this video is roll cage, how to create 1D meshing to a roll cage structure that I am going to cover in this video. So let's start our session. Open HyperMesh 12 version 12. Select the appropriate user profile. I have selected user profile as radios bulk data. Then the next step to create 1D meshing using HyperMesh. There are 2-3 ways available to create 1D meshing in HyperMesh. So in this video I am going to show you one of the most easiest and simplest way to create 1D meshing with the line CAD model. So if you have a line structure model of a roll cage, then how you can create 1D meshing. So first import that line CAD model in export them or save as those CAD line models in IGS format, and then once you open the HyperMesh, click on import and select the file type. Click on the import icon. In import icon, then select the file type as IGES, because for the structure I have IGS format file. Then the next step is to click on folder option, browse folder, to select the location to import the file. So I'll click on browse folder, select the roll cage line data .igs file and click on open, and keeping all the other parameters as default, that is the scale factor as 1, cleanup tool as automatic, I'll click import. Then I'll close model browser. So now you can see my line data of the entire roll cage has been imported. So now we will move towards the next point of this video, that is how to create 1D meshing or 1D elements for the entire geometry at once. In HyperMesh you will find some unique and interesting features in which we can create 1D meshing quite easily using HyperMesh. So I will show you how we can do that. So it is always better to check the elements quality and connectivity for the every time we can check the meshing types, element quality. That's why HyperMesh is the most preferable tool in nowadays automobile industry, because in HyperMesh the mesh quality is very important and you can improve the mesh quality in HyperMesh UI. So it's better always try to check the mesh connectivity and quality. So that also I will show you in this video. So for that we will go first with the creating cross-sectional diameter, that is cross-sectional area of my 1D beam element. So for the roll cage structure I am going to use a hollow cross section. So I will create a thin wall tube selecting a cross section. So for that in HyperMesh you will find one more different panel. So to enter that you can select to 1D page. In 1D page click on HyperBeam to enter to HyperBeam panel, through which you can provide cross-sectional area, or you can define the cross-sectional area or cross-section of your 1D element. So click on HyperBeam. In HyperBeam select the standard section radio button, then select the standard section library as HyperBeam and standard section type as thin wall tube. So select the standard section radio button. From the drop box select HyperBeam as standard section library, because we have a predefined HyperBeam library where are different types of cross sections are already defined. You have to just input some of the values to that and it will create a cross section accordingly. So for my structure, the type of cross section I am going to define is a thin wall tube, that is a hollow cross section. So I will select thin walled tube and then click on create. So once I click create, it will redirect me to HyperBeam GUI. Here I have to just provide the inner and outer radius, then it will automatically calculate the area for this particular cross section, centroidal, moment of inertia, polar and radius of gyration, then shears, center, principal, shear forces, everything it calculates automatically by its own, and will input the required data as per my type of analysis and requirement. So first of all, I will enter the radius as 12.7 and inner radius I will enter as 11.2. So this is the cross section I am going to create. For this cross section I am going to create 1D elements. You can change the cross section as per your requirement. So the cross section of the inner and outer radius of your pipe, you can enter it from here to simulate the actual practical problem. Then once you define this, you can see here it has calculated the area, moment of inertia, centroidal, principal, planes. So it has calculated everything. Now I will assign this to create 1D element. So I'll again go to HyperMesh GUI and assign them and create 1D element using this cross section. So click on that icon to move towards the 1D to HyperMesh GUI. Then click return to exit the HyperBeam panel. So in model browser you can find here the HyperBeam has been created. So if you click plus, it has created an HyperBeam cross section. Now my next step is to create material and property for my 1D element. So to create material, I will click on material icon. I will define the material as steel, giving appropriate color. The type of material I am using as isotropic. Then define the card type as mat 1. Then I will click create edit and enter the values of E, new and row. Then click return to exit the material collector card edit, and then again click return to material collector icon. So in this way I have defined the material for my roll cage structure. Then the next step, I will define the property for my roll cage structure, that is the physical property for my roll cage structure. So to define the physical properties of my roll cage structure, I will go to property collector icon. So I will click on property collector icon. Make sure the radio button create is selected. I will enter the property name as roll cage 1D. Select an appropriate color. Define the type of the 1D element I am going to use as 1D. Then select the card image as P-beam. That is, we are going to use beam elements to create 1D elements for the entire roll cage. Define the material which I have created earlier. In the earlier step, the material which I have created, I will define it here. And then I will define the beam section which I have created in HyperBeam GUI. So I have defined all the things. Then I will click on create edit and I will check the required data which software will require to simulate 1D beam element. So it will require area and all the parameters which is required. It automatically takes from HyperBeam GUI. So then I will click return, and again I will click return to exit the property collector icon. So from here you can see the property has been created. Now my next step is to create 1D elements. So to create 1D elements in HyperMesh, we have a unique feature called line mesh, through which you can create 1D element at once by selecting all the lines. So that I will show you in this video. So to enter to line mesh panel, go to 1D page. On 1D page you will find line mesh panel. So click on line mesh. On line mesh, make sure the lines option are selected. There are two options through which you can create the meshing, that is nodes and lines. So make sure the line option is selected. Enter the element size as 50. So it will create a element of length 50. Make sure the toggle is set to segment in whole line, so it will create a segments of 50 50 50 for the whole line. Select the element configuration as bar 2, so it will create a beam bar 2 elements. In bar 2 we have bar elements as well as beam elements. Then select the appropriate property which we have created earlier. So click on the property and select the proper property. Make sure the auto segment here is selected, that is we don't want to define the vectors, components and nodes to create 1D elements. We directly create by auto. Then click on line and say displayed, so it will select all the lines which are displayed on the GUI. Again I will show you, click on lines and click on displayed to select all the displayed lines of the GUI, and then click on mesh. Once you click on mesh, it will create the 1D mesh for the entire domain. Then click return to accept this meshing. Again click return to exit the line mesh panel. So now you can see it has created the 1D meshing, 1D elements. I will change the color of the component. It will create a new component for 1D elements which contains the 1D elements. So I will off the geometry component from here. So I will hide the geometry of the model and on only the meshing which it has created. Now my next step is to define and to check whether the cross section is defined on all the elements or not. So in HyperMesh you can easily see the 3D representation of 1D or 2D element also. So to view the 3D representation of 1D element, you can go to click on element traditional element representation and select the drop box and select 3D element representation. So this is the 3D element representation. So in this way you can see the elements are the 1D elements in 3D representation. So if I mask any one element to check the whether the cross section is appropriate or not, so I will go to mask panel, click on mask icon, select the radio button as mask. Then from the drop box I will select an element. I will pick the element and say mask. Then I will say reverse, so it will only show me that one particular element. So if I rotate this one element, so you can see it is a hollow cross section. So if I move it to a traditional, it is a line which is the actual representation of 1D element. But in HyperMesh you can find the 3D representation of 1D element is as it is shown here. So you can see it is a perfect cross section. Then I will again click on unmask all. So in this way I can do the meshing for my 1D element entire structure. Now I will check whether my elements are connected or not. So I will click return to mask panel. Then to check the elemental connectivity, I will go to tools page. On tools page, click on check elements. I will again show you. To check the elemental connectivity, go to tools page, check elements. Select 1D radio button and click on free 1Ds. Once you click on free 1Ds, if any of the 1D element is not connected properly, it will show you the message here. But on this model as all my 1D elements are properly connected, so it's showing 0 1D element found with 0 free ends. So all the elements are connected, all the 1D elements are connected with each other properly. So I will click return to exit the check elements panel. So in this way I have ended with the tutorial for 1D meshing of a roll cage.